friends, welcome to Engineers Technical Academy. Today we are going to discuss one question which were asked in GATE 2017. So come to here. This is the question. I can read it out. Transistor Q1 and Q2 are biased at a collector current of 2.6 milliampere. Assuming that transistor current gain are sufficiently large, collector current equal to emitter current and thermal voltage of 26 millivolt, the magnitude of voltage gain Vu upon Vs in the mid-band frequency range is dash. This was asked in GATE EZ 2017 set 2 of 2 marks. And this is the figure given to us. In this figure, what we can observe as there are two transistors, transistor Q1 and transistor Q2. Suppose we are seeing transistor Q1. In transistor Q1, this is your base terminal, this is your collector terminal, and this is your emitter terminal. Okay. And in transistor Q2, this is your base terminal, this is your emitter terminal, and this is your collector terminal. Okay. So in transistor Q1, we are observing that there is an input voltage which is placed at base terminal. Okay. And at collector terminal, there is an output voltage. So the only terminal which is left, it is known as emitter terminal, which is common in both sides, in input side and output side. So we can recognize as Q1 transistor as common emitter transistor. Same goes on Q2 with, and after observing in Q2 transistor, output is taken from collector terminal and input is coming from emitter terminal. The only terminal which is left is base. So Q2 transistor is your common base transistor. Okay. What we were asked in this question as we need to get the value of voltage gain that is in the range of mid-band frequency. We are having one formula to get the value of mid-band frequency range, that is this thing which I can write as AV, that is the voltage gain, which is equal to output voltage upon input voltage, that we all know, and it is equivalent to, as it is the gain, which is minus Gm RL dash upon 1 plus Gm Re. On going the values, the name, what are the things given to us? Gm is your transconductance gain, RL is your load resistance, Re is your emitter resistance. So after observing these things, the given things to us in this question are beta, that is very large, it is given to us, that is large collector current, so beta is very large. IC, if beta is very large, then we can assume as IC is equal to IE. And if IC is equal to IE and IC is given to us, that is 2.6 milliampere, so IE is also equal to 2.6 milliampere. Thermal voltage is given to us, that is 26 millivolt. These all things given to us. So in the formula, we can get the value of Gm. We also know we don't know the value of Gm, we don't know the value of RL, we don't know the value of Re. In identifying this question, we don't have the value of Re. We are not able to recognize where is Re, emitter resistance. So I have one trick to identify where is emitter resistance. This emitter resistance can be replaced from this common base transistor. So to get the value of emitter resistance, we need to model this common base transistor into its required model. So we are having 2 or 3 models to replace this transistor Q1 and Q2 and to get the value of voltage gain. So I have the analysis for these 2 models. So first go on the analysis of those models, then we are going to come back this question. Okay. So this modeling is known as transistor modeling, and it is also known as small frequency zoom small signal model. It is known as BJT modeling. In this modeling, we are having a black box which is like this. In this black box, we are having one transistor. This is common emitter transistor. In the left hand side, we are having input port, and in the right hand side, we are having output port. In the input port, I1 current is going inside the black box and V1 voltage is placed at the output port open circuit voltage, and I2 current is going inside in the black box and V2 is the output voltage. at the output side. If we are supposing this as a two-port network, so we can write the equation for hybrid model that we all know, that is V1 is equal to H11I1 plus H12V2. I2 is equal to H21I1 plus H22V2. Okay, so now we are going to replace this model with its equivalent model that is known as hybrid model, and we are going to use the values of H11 as, this is H11 will become as HI, that is known as driving point impedance function. H12 will become HR, that is known as reverse voltage gain. H21 will become HF, that is short circuit current gain. H22 will become HO, that is driving point admittance function, right? So after placing these all things in the model, it will looks like this. HI will come over here, that is the resistance. HR is the voltage at input side, that is dependent voltage source, and HF is the gain, current gain, that is the dependent current gain at the output side, and 1 upon HO, that is the resistance. Okay. Now this black box will be having input from left hand side, this is the input, and this is your base terminal, this is your collector terminal, and this is your emitter terminal. So all the things are same which we were assuming over here, and all the things are having the same name, and there is a very small change that we are observing over here, that is V1 is equal to HI now with the H1 in multiple plus HR V2, and I2 will become, I2 is equal to HF I1 plus HO V2, right? After observing this figure, we are having some complication in our mind that this figure looks very complicated. We cannot use this figure or this model, it is very complicated one. So we need to model this transistor, or we can say this model in its approximate model. So in its approximation we need to assume some parameters, that we are going to assume HI as R pi and HO and HR as very small values. So it will look like as this thing. It is known as R pi model, in which this is your base terminal, this is your collector terminal, this is your emitter terminal. From base to emitter there is a resistance that is known as R pi. From collector to emitter there is an GM V pi current source, and it is known as GM V pi, or we can say beta IB. So from observing this figure we can say that beta is equal to GM R pi and GM is equal to ICQ VT. So we are going to use this formula over there, so please remember this thing. Okay, the very new other formula that we are going to use in this figure, that is common base. For common base we are going to use T model, that is known as RE model also. In this, if we are having current is coming from collector terminal, and input is your collector terminal and output is your emitter terminal, and base is your common, that is common base, and we are going to replace it with this model. In this, it is your base terminal, this is your collector terminal, this is your emitter terminal. IB current is coming from base terminal, IC current is coming from your collector terminal, and they are going to merge and will become IE and they are flowing through RE. And this RE we can get the value RE is equal to 1 upon GM. So we are having these two things which we were required to solve this question. Now we are going to use these two things in this question. So it will look like, so just go on this thing. GM is equal to ICQ upon VT, and ICQ is it is given to us, ICQ is equal to 2.6 milliampere. VT is your 26 millivolt, so it will become as 1 by 10 that we have get, and RE is equal to 1 upon GM. RE is equal to 1 upon GM, and it will become as 10. So these two things we were required, and now we get this thing. Now for RL we need to model this transistor into its model, then we can only see what is the value of load resistance. So now it is very easy that we can model into R pi model this transistor. Now it has become, now we are going to replace this base, common base transistor into RE. So it will look like this one. This is your RC this is your RE, and this is your emitter terminal, this is your 5 volt, this is your ground, and this transistor is modeled as this is your emitter, this is your collector, this is your base, and from base there is an input connected, that is Vs. From collector there is a resistance connected, that is Rc, and here is your output terminal, and from Re we have find out the value of Re resistance, and this is your collector current, this is your R-pi model. Okay, this is your Rc. We have the value of Rc in question. It is your 10 kilo ohm. We have already find the value of resistance, that is Re. Now, if after placing, we can identify from model the only value of load resistance is your Rc. So Rc will become RL. So now we are having the value of RL also. We are having the value of GM also. We are having the value of GM RE also. We are after putting these all things in the question, we are going to get the value, that is GM is your 1 by 10. RL is your 10 kilo ohm, 1 upon 1 by 10 into 10 will become as, sorry, it is your 1 kilo ohm. Okay, it will become as 100 upon 2, it is your 50. So 50 is the right answer for this question.